Welcome to part 6. Let me quickly set this up here. So here we go. Yes. Where did we leave? Oh yeah. So we were working on this little power outlet here, and we were running out of these terminals because the cables I had were not long enough, and I forgot to take another cable. But I ordered more of these. And this time's also the nice ones. They have like the protective housing in there. No, not housing, but like this like cover basically. So what we did here with the shrink wrap, we don't have to do that. It's not like all included here. So this will be nice. They also shouldn't last me for a second. Like from all these like cable shoes, cable lines, how they called in English. These are the ones I use the most. So it's good to just have a separate pack for that. Oh yeah, I also got this. So now we can use the reamer properly. um, and yes, we need to inspect the cable. I understand that. And most importantly, this arrived this week. Don't eat that, cat. This arrived this week, and this is made by Ravenkeeper, who's also part of the community. He CNC machined those panels for me, so it is quite exciting. Because we can now start putting panels. The only thing that didn't arrive yet, and with a bit of like planning ahead and like all these good things, don't eat that. Hi, Patsumir, welcome. With a bit of planning ahead, I would have ordered already the foils. So these are all like transparent. So it's just like the white cover film here, but they're like all transparent. Which is fine for all panels, but for two, which is, I'm actually not quite sure which ones these are, but there are two panels that basically go here in between. And those should not be transparent, of course, because these separate the electronics compartment from the main compartment. You don't want to see through there. And for these, I need basically like a film similar to what is on here, but like nicer in black, just to make them like black. I also thought of spray painting them, but I think that's not super durable because like scratches off most likely quite easy on this material. So I ordered the foil. I have white marble and I have oak, but I don't have like a black. I ordered that, but yeah, that's still in the shipping. So that's pretty cool. So I'm very excited to have these here finally. We actually, for now, put them to the back. Um, but for the time being, let's just continue with the outlet here. Oh, also, I got a hot end that we can use, and that is somewhere. That's it. Kind of preliminarily put this together. So this is the Fetus Conch hot end, which is like basically it's compatible with the Bamboo Lab hot end system. So this fits perfectly into the ready-made part we already have from this printer. I also reused the thermistor and the heater from the TZ hot end we wanted originally to be in here. And yeah, this is like very tight here. Like it's very, very hard to maneuver this in and out. So I'm not sure if we really have to take this off again. Ideally, we don't. I think we need to add a little bit more thermal paste between the heater and the heat block. But besides that, I would not try not to pull this out again. Like I maneuvered it in to see if it fits. It fits, but it's tight. Um, yeah, I'm quite excited. Like this looks to be like a very nice hot end. It's an integrated nozzle, so it's not like a nozzle you can remove. It's just like an integrated press fit nozzle. There's a version of this hot end with a standard M6 nozzle, but I wanted to have the maintenance-free, zero hassle version. And this should give us somewhere in the neighborhood of 30 to 35 cubic millimeters of flow per second. So quite a capable hot end. Let's see how this plays out. Cool. I also printed little spacers that we can use for our spool holder that we want to put in. But actually, before we start with anything print related, let's just quickly go back to Fusion and get a little bit of an overview of where we are. So things we could do by now, actually, we can put in the bottom panel, which I will keep transparent, I think. I kind of like that if it's like open. So potentially we keep that transparent. Not 100% settled on that yet. The other thing is, the nice thing is like these panels, I think we can easily apply later. Because they have cutouts for these spool holders here. Also, this spool holder we don't have to assemble yet, maybe, but let's put it together. So my goal for today is basically that we work on the toolhead. So I kind of want to put this one together because we have all the parts now. That also means we need to make a decision on what kind of like setup we want to have here. Either we go with canvas or we do like a standard old school cable connection hot end, which is kind of my current favorite. So let's see. We can have a vote later on. Besides that, yeah, let's just jump in. Let's finish this outlet. But for that, I quickly need to go under the table to grab the power cord I want to sacrifice for its guts. 1 second, I'm right back. Here we go. So this one will die. It had a very short but beautiful life. And then basically we can use this to create all the connectors we need. Okay. I'm just double checking that I unplugged it. It's not would not be the first time in my life that I cut the power cable and kind of forgot the end. It was still plugged in. Let's see. We don't need like a lot of that for now. Let's just grab something like this, and then the rest is for the next printer. Can we pull this? Not really. Okay, and let's just. You want to help? See, so we didn't cut deep enough. Here we go. Now, once you have one out, usually you can just pull. If you would have pliers. Here we go. Exactly. And then the other just fall out. You can have this one. Do you want this? That seems interesting, right? Have fun. Okay. This we can already trash. So I'm just wondering, I think like just to have it nice, let's use the same cables. But again, these are like thinner. Also 0.75. Nice. But these are saying they are good for 0.5 to 1.25. So I think let's just give it a shot if we can crimp that nicely with these. Grab my crimping pliers. Do you think this is good cable quality, Loki? Let's see. I never used these ones. But it seems like we can just completely push them in. And then squeeze. Yeah, it's exactly the same as last time. So this was not a success. I should have tested it, but it just arrived today. Um, let's try to follow him. If we remove a bit more and fold it over, maybe then we have success. It's not ideal, but because everything is in this housing anyways, I think this will be fine. Maybe it's also my pliers not like crimping them enough. Because like these are definitely for 0.5. These I need. Can you lift them? Let's see. If we fold it over. Yeah, like this it works. Okay. Then let's do a second one. And then this time, let's also don't mix up the neutral and load colors. Yeah, that's good. Okay. It's always the other way that I think. So load is brown. So we make a short loop here. It's this one. This can be quite a short loop, so let's just do it like this. Mhm. Okay. So then we have the loop here. And I think this is still plenty long. What are you eating? Can you please not eat my hot end? He's like way too active today. Not a good sign. Hmm. That did not work. Quickly try it one more time. It's a bit tricky with this folding over. It's like these are quite tight to put in. So I'm really confused why they don't hold that cable. Let me quickly make a toy for him. Hi, that's a wolf. Welcome. So Satsuma is like a VisiBot made from Prusa parts. Well, yeah, might be quite a similar concept to the VisiBot in general. But it's yeah, like a more um, simple project compared to the VisiBot for sure. I think the VisiBot is a lot more high end. It's not getting better. Why did it work now twice and now it's problematic? Yeah, not worked. Yep, that's good. So this goes on the other side. We double checked it with the multimeter again in a second just to be sure. Then this one we swap out. That's -1. Yes, I'm not quite sure. Like I have to fold this over like in a very specific way to make it work. I'm not sure what the specific way is yet. Yeah, the folding over is it's not perfect, but this is what we'll go for now. If it passes the tuck test, I'm happy. What are you doing now there? Yeah, that's great. Okay. Well, I guess I can pull off. But just want to check this in the, because you can also like put them between the plastic part and the metal, and then they don't properly sit, but that's not the case. Cool. So this is the connector. So it connects the power plug with the switch. So we switch the load side, I hope. Should be. You know what? We can actually quickly just try it out. I'm a fan of practical experimentation. We plug this in here, and then we take a multimeter. We can quickly check that everything is correct. So yeah, so that's blue to blue. That works. And at the moment the switch is off, so we should not get brown to brown, which we don't get. Cat, did you hear when I said I need those? And here, let me quickly remove a bit of isolation. So brown to brown we should now get. But we don't. Oh, I think where's the mistake? Okay, here we have a connection. Here we don't. Is this cable okay? Check here. Here we do have a connection. Oh, I think this needs to be here. I think I plugged it in incorrectly. So, no? Where's the problem? Oh, the switch is off. There's the problem. Yeah, it needs to be here. So I plugged it in incorrectly and I turned the switch off. So now it's correct. So now we have continuity. And if I switch the flip off, switch the flip off, flip the switch off, we don't have continuity. So this is correct. Okay, perfect. Perfect. Then let me quickly clean up here and then we can put that in already. That can go to the trash. Perfect. And this cable we will use next time. Okay, then printer. So we have this little like cavity here where this needs to go in. And last time we already discovered it's quite iffy to put together in the right order. Because there's like this back cover here that slides on, but then you have to do that before you screw it in. And then you have two screws here that you access through the holes, but once the plug is in, you cannot access them anymore either. So all needs to be kind of put in the correct order. Just a second. Get these all out. Let's check that everything sits correctly. Like once this is in, like I honestly don't know how to get this out again. Like seriously, I have no clue how to get it out again. I think you have to like have a little bit of force on this back panel because you also don't get this one out again because it has these like little like latches here that you can only like undo from the back. But so now it's permanent. Almost. Perfect. And then we have one of these panels. Oh, it's actually the top one. This goes here, and this has a cutout for this thing here. It's only the protective film is like fuzzy. The panels themselves are not. So this looks good. And then I think we can continue with the spool holder. Let me actually move the bed up that we have a bit more space on the bottom there. So the spool holder was also something like we kind of like couldn't complete last time. So this basically goes on top here, I think. Was it this one? No. Let's quickly check Fusion. No, I was right. This goes on top there with this part on the side. So these two complete this block here. And these two create your own block. And this part I reprinted. I actually didn't check it, but yeah, it's better. So like the edges were a little bit warping. Yeah, you can clamp on this printer. It's not perfect, but it's kind of okay. And it's like this anyways from the front. Then the other thing we were missing were these spacers. So basically they were not part of the Fusion. I just created them quickly in Orca Slicer. I didn't even like sketch them up in Fusion. Hey cat, why are you so active? Can you be tired and just like sleep for a bit? No option. Hmm? We played like for half an hour before the stream. Usually that's like your sign that's like time to sleep. Let's see if that happens. Where did I put the bearings? Yeah, you can play with these. Have fun. Oh, I'm missing a box. Totally forgot. I'm missing a box here. I have so many like different project boxes for this one. Here we go. There are all the bearings. And then we need square nuts. think also here actually. No, these are the wrong square nuts. I'm not sure if I like this spool holder. Seems very limited in a certain sense because you can only take spools of a very specific width. Oh, actually, before we put this together, let's quickly use the reamer and clean out the holes. Hi there, Steve, welcome. Guess you don't want to switch light to work. Switch light to work, or you wouldn't have looped the blue. The light doesn't work now? Did I do it wrong? To be honest, now it's too late. I'm not going to take it apart again. Let's quickly clean this out. There's some sacrificial layers here as well. I'm just quickly punching through the sacrificial layers. And then we can kind of like push in these nuts if they want to be pushed in. Yeah, it's quite tight. Let me see if I have more like clean this out of it. Yeah. Quickly. No box is too small for a cat. This one does not go in. I'm not sure why, because there's nothing in here anymore. Ah, there it goes. Just needs sufficient force. Let me quickly clean up here a bit. A bit more space. So this should be fine, except for this one. Like this nut sits a bit too high up. Let's see if we can make it work. Then we have the spacers that we didn't have last time. So these spaces are now 6 mm. And I seemingly made them too tight. Great. Let's see if this works. Seems good. Let's try the next one. Let's not do that again. That's a problematic one, so I'm curious if we can get this in. Seems like a success. 2 more. Hi there, Harlem. Hi there, Raj. Welcome. So, okay, a lot more successful than last time. You know what? Technically, we could have used also washers here. I actually have them. Are they? Yeah. Maybe let's do that. Just, you know, like that it like properly runs. Like that the bearings like have like a nice surface. If they're like falling in my hands, like without the washers or the shims, it's already good enough. That's of course better with, because then like the screw head doesn't rub on the bearing. Yeah, it makes almost zero difference. Let's first do the other one. Let's quickly add the washer to this one, and then we can mount this to the frame. Hey, can you stay away from here for a second? It's like a lot of dirt. It's the ultimate tool to remove him. He gets way too used to it. Like he's still sitting here, like just off camera. He's way too used to get to the vacuum. So this one is the centerpiece that kind of goes here somehow. We'll figure this out in a second. Something like this. And then these are also interesting in a certain sense. Because here we have only single bearings, which is... I'm curious how this will work out. Because we only have 2 bearings left, basically. And also in the Fusion file, it only has... Cat. It only has 2 bearings. So I think per se, it should be pretty much the same. So what I was thinking of doing is basically just having the bearing like this. And then the spacer. That's basically riding on the inner side of that. I'm just curious if that works out with the screws or if the screws will collide in the center now that I think about it. So I think now the screws are too long. Yeah, because like now this screw is almost at the other nut here. So if I now put this in here as well, they are like too long. So from the front they all look the same now. How about we quickly look for a different screw than this? That's a tad shorter. I think the M512 is too short for sure. So we need some other M5 or I need to cut one. That's also an option, but I don't think I'll cut it on stream. Yeah, when I put it in, like there's definitely like quite a healthy overlap between them. So that will not work. Also looking again on the order to put this together. Because here we have 2 access holes. Oh, there are 2 more screws here holding this together. There are 2 more slots. Same here. There's 1 slot from the back. Okay. But yeah, this one does not work out for sure. I'm not quite sure if I have other M5s. It's really like a dragon hoarding its gold. He's still very suspect of that, but he stays. I'm not sure if this is a good thing. I'm not sure if this is good. It's also like yeah, that's also like a problem for maybe. Oh, it's also like what kind of screws are supposed to be used here? Oh, it's definitely the M3. So my M5 35s have a little bit wider heads than I think what is intended to be used here. And it just fit. Let's see if we can make that work. Let's see if we can make that work. Nope, they're just too big from the screw head here. Let me quickly see what my magic screw box has to offer. Let's see. Oh, this one, that might actually be like it's kind of a stupid screw, but this might actually, this is M525. This might just solve the issue we have here. Ah, so this might be a solution for this one. So we have M525. And that just reaches, so this works. So this is the solution here. Let's see. No. Okay, let me use screwdriver. Wait, I have the sun in here. Oh, maybe we should have also put like a washer in between here. Let's quickly do that. I kind of like that there's a spool holder inside the printing chamber. Because I kind of like when you have filament that's hydrophobic? No, hygroscopic. Like that absorbs like water, and it's inside the printing chamber, like the temperature is higher, so it doesn't absorb as much moisture while you're printing. I think that's a nice feature. I'm not quite sure if this is the intended purpose, but it's definitely the effect. And it's such a, like, look at the screw head. This is such a weird screw. For something I needed the M3 by 25, and this was the only thing the hardware store had to sell. Okay, so this solves this problem. Then we still need to have something here that has M3, M5. I think these are just too long. I'm at the moment screwing into the sacrificial layer ABS here. Yeah, it does work. Okay, let's use these. So there's seemingly bit space behind. I hope that's the same here. It's always nice to have like a random assortment of screws. I also have here like one box with like completely random one-off screws. And more often than not, there's something in there I can use. I'll try this one first. I'm just careful if I hear any cracking because I don't know how much space there is behind the nut. But we are on the bottom here and it tightens, so I think it's fine. Then the second nut here. Let's use the same type of random M5 screw with a flathead. I was not sure if these screws are really needed. I have very strong suspicion they're not, because like you have like two screws holding it here, and you have two screws going through here. So maybe you can argue something to pull it together visually there on the bottom, but like they're not really. Gives it a nice weight though. Okay, and then we have two screws from here, but this might be actually the similar problem because these are just too wide. That is actually a problem. So basically, the flathead screws I have here are not the typical flathead screws that you should buy. So this is completely on me. Quickly clean this out. Yeah, now like on the end, they're just like too long here. That's not. They're too long. So for this one, I don't think I have a good screw at hand because it needs to be M535. Yeah, I actually have like a perfect, but it's M540. It's like, it's a bit too long. But I have two of these. What do I need here? I don't know if you can see. So how is this mounted? Oh, there's one hidden screw here, which for sure is also M335. Yeah, perfect. So there we have the same issue here with the screw head, just being like, it's really not a lot, it's like a millimeter too tall. Let me see. Yeah, I think I will use the nice ones here. Hi, the Hexacom, welcome. Are you going to close it? Yes, the panels are here. That will be happening. But it doesn't have a top panel by default, so it's only the sides and the top is open. That might be something we'll change in the future. But I think then these we cannot mount properly. So I have 2 times the nice bolts here. Nice because they look like how they're supposed to look. Oh yeah, maybe I can put this out. So this is the problem. So this is like what I needed, and this is what I got. So you see they have like extra ring here around. Like the head is the same, but then there's like this like inbuilt washer. And that just doesn't fit in this part here. It's just like a bit too big. But I think I need to prepare for next stream. Then I just cut a couple of these screws. I have to do with the hacksaw. But then basically we need one hidden here. This one maybe kind of can do with one of these, I guess. We don't have to shorten that. And then one for here. Oh, this is 12. There we can use M312. Yeah. I don't hit the hole, but yeah, it's M312. So we need 3 shortened screws. So that's something I can do for next stream. So I'll just put these on the side here. The other option, I have these M330 bolts, but 30 is too short, so it doesn't work. Yeah, so that's something I have to prepare for next stream. Well, but the question, does it actually fit spools? And yes, this works. So this is, it functionally works. So that's good. I was a bit concerned about the spacing, but this looks to be quite okay. Then I would park these parts for now. I shorten these screws. And then we continue there next time with these. But then I would say let's transition to a tool head. Because that's the interesting part. And for a tool head, the big question that I have is whether we do canvas or not. So quickly, roughly clean up here. It's okay if it's here, but if it's here, it's too close. So basically we can use 2 things for the tool head here. Let me quickly grab that. So this will go on like this, basically. I already like put in the hot end here. So this kind of like fits together already. Then the Pinder probe will be here on the front. I have that here. And then if we check Fusion, there's a mount for the ADXL sensor here in front. We're not going to do that. Which then we're not gonna do that. No, we're not gonna do that because the ADXL sensor is inbuilt in the toolhead board. So basically here for a toolhead board, we have 2 options. The one option is that we use EVB36, so it's quite standard. Or we use the toolhead board that came with the V0. I built the LDO V0 kit a while ago, and there we have this Toolhead board, which exactly like this has this like 2x10 pin connector microfit. And I kind of want to use that, to be honest, and not use canvas, because I'm still thinking, like playing with the thought of using Marlin instead of Clipper on this machine. And if we now use a canvas toolhead board, we kind of like close the possibility of using Marlin or anything else besides Clipper on that machine. So I kind of want to have the option still. Are you going to sleep now? No? So very interested in what we're doing here. So I think we're going to use the board of the V0. Let me quickly get that. Quickly get that. So we have this breakout board, which again we will not use. But on the other end, we have this little toolhead board. And this should be perfectly suited for what we need. So we have the same connector here on top, which then like breaks out to all these different connectors. But also this has an ADXL sensor on board that you can connect with this little like flat band cable here. So I think this is like what we're gonna use for toolhead board. But again, like I think having, let's see. Yeah, this is a cable, but this is of course V0 size, so this is too short. I'm not sure if I still have these connectors. I need to buy most likely a couple. But this is the only thing we need. Let's put this back. Okay, then this is our toolhead board. And then on top we have the orbital extruder here, which also is LDO, so it's quite good. So this is basically what we have. Because we already belted everything up, we kind of have to install everything now here directly, I think. Maybe we can prepare the front part here individually, but there's not too much we need to do. Like we need to have 2 screws here. We need to, oh, the fan. Yeah, the fan we also need to set up. Yeah, let's get it going. So we need a fan for that. Where I need that fan? So we need a pin down probe. I'm not sure exactly how that mounts. I think it's just like clamped with this like green piece. He's like really interested today in what I'm doing. Usually like after a while, he's like, okay, whatever. So this would go. Let me quickly turn that here a bit. Oh, it's also completely I was seeing here like it's like configured in stream. Here we go. Okay. So the pin there. Yeah, it basically goes in here in this clamp position. I'm not sure about the distance between the nozzle and the pin that drop. That's something we need to look up. What exactly we need there. But here are the other parts. So I think this is something we need. This is something we need. This is something we need. Oh, this one I have twice. Which one is nicer? This one is nicer. And this is the mount for the ADXL, but we are not gonna have that. Okay. Yeah, this is quite nice. Like just like hooks in here and then you clamp it down. Let's quickly check here in the model. And just isolate that quickly. So from the nozzle tip, I need to select the surface here. Easier said than done. So that's 1 millimeter above the nozzle. Let me see if I can. How do we do that? So if we just use this box as a reference point, maybe? Kind of have to over a bit. I think like this is good. Okay, then there are two square nuts, one here, and then we can pull it together. And then the question becomes, what kind of hardware do they use here? Find the browser. So this is M310. Okay, I'll put this here, and you will not move that, Loki. My mess here is not getting better. Well, what I can do? No, you're not gonna go up there, please. I can actually get rid of all these bags here because they're all. You want to play with this? They are all empty. M310. Here we go. So we need two of those. And then I think so that's the M5 square nuts. You can see in a second where the M3 square nuts are, but for now we have enough. Oh, that's too big. Okay, let's see if I can. I'm not sure if I get the square net between the heatsink and the printed part. Okay, let me first secure it in place with the other one. And it also didn't work. This is like the nut. And now see. Maybe let me try to remove quickly the hot end again. It's a bit of a wiggle, but no, okay. Ah, I leave it. Because I also like if I now put the nut here, it will be even harder to put the hot end in. And that's like really tight. But now see, like the nut needs to be completely through here. Ah, now it is. Okay. Yeah, okay. So this one is on okay. And then here we have to do the same. So it really needs to go. Where's this square it? I think these are like a little bit wider than the ones I'm supposed to use. And it just doesn't go behind the heatsink here. I also don't want to force it. We should definitely use thread locker on this one though. Because I can't tighten this down because then like I break the plastic part here because it's kind of like just like clamping this. I wonder why this is designed like that and not in a way that you can just like screw the pin in. Let's see. So I have new thread locker. Let's be really. I have to cut this here. I have to cut this. Very delicate with the thread locker because ABS and thread locker don't like each other. This is already enough. And I can't like tighten the screw, so we definitely need thread locker. Then what do we do here now with this nut? So this is not. I also want to like damage the heatsink. Okay, let's try to remove the hot end again. Oh, there's definitely possible now because the nut, yeah. So the nut stands out here like maybe like 0.2 millimeters. And that's why the heatsink now like definitely doesn't go out anymore. So my nuts are just like, it's the same what we had with the M5 nuts, like they're like not 100% the correct ones. Let's do the following. I will use a teeny, 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 tiny drop of super glue here on the thread of the screw. If I can open it. Ah, fuck. Okay, the super glue is gone. I have to use the pliers again. This happens like sometimes. But then let's just leave out the screw. One is good enough. This is holding the pinner probe in place just fine. So I will order the thinner M3 square nuts and then we can get the second one in here. But then let's get the hot end secured here. So there are two screws from the back. If I hide this fan here. Oh no, it's not behind the fan, it's behind. Wait, where are those screws? Quickly dig through here. Oh wait, I'm on the wrong side. Wait, let me quickly orient myself. There should be across from the Pinder probe. Oh, so it's in between here. Okay. Let me quickly hide the entire part here. Here we go. This is what we need. M314, that's very specific. Let me see what we can do there. So we need, but it can be also longer. There's a lot of space here. We put the two M3 square nuts in here. If they want to. Yeah, let's do one first. Then let's see what screws we have. Because I think I put out, we have M316s, which I would give a shot. That should be fine. Hey, that's right, roughly not a twine. That was not smart. Also was not smart to put the Pinder probe. Cat, can you? Before mounting the hot end. That was not smart. I don't want to remove it again because of the thread locker. Here we go. Yeah, that's perfect. We can use the M316s here. Just have to maneuver that. Cat, can you just for a second let me do my thing? See if we can convince this nut to go onto the screw. I think that's not gonna happen for whatever reason. Here we go. Okay, that's one. Where did I put the second one? Oh, here. Put this in here. Yeah, perfect. Okay, those are in place. Then I would say next up, let's put the fan. Where did we have the... Oh, I know where it is. 1 second, I have to grab it. Here we go. This is the fan we're going to use. It's a Honey Badger fan from a V0 kit. That's that. No, is that a wrong fan? Did I misread something there? Yes, I did. This is a 30 by 30 fan. We need a 25 by 25. Well, I was convinced that's the same fan. Ah, okay, well, then we have to do the fan separately. Because like this doesn't fit, obviously. I mean, this would work. Technically, you can just super glue the fan on here and it would work. I think the size is just perfect. But let's not do that. I don't have a 25 fan for sure. I thought these were 25. I did not check, which was not smart. You really annoy me today. You know that? Can you do your own thing? That means we need to do that next time. I'm looking at this green thing here, and that just holds the cables in, I think. But I'm also looking at this. This is like a separate printed part. Because mine looks different. So basically, like the Pinda cable is supposed to go here. So this is for the Pinda cable, which is fine. But then on this side, yeah, this is a separate printed part. Quick check. Yeah, here. So this, how does this connect here? Oh, the slide's in here. Interesting. Like there's a slot and it's just, oh, I see why. So this was basically separated out so that you can print this flat and then like this just like slides in here. This is a cool design. We also shouldn't forget the bottom tube. That would be classic me. Then this goes up here and then it's covered by, it's a green part, right? Yeah, this green part here. No, where's this green part? Here it is. So that goes here, but then I wonder where the cable is supposed to go. I think the cable is supposed to go around here, like this. Okay. And what are you, screws? The browser. That's a M310 flathead. So seemingly we just screw them directly into the plastic, which is fine. So, but then let's use black ones actually. For this one, I want to use black screws maybe. I do have. I have. Oh, I do have 10s. Perfect. Does that look like you can screw it in? Yeah, that works. I actually saw this video from Made with Levels, I think it's called, where they compared like different types of how to screw into plastic, like directly like this, or with printed threads. Let's make sure I don't pinch the cables here. Or with heatsed inserts, and like strength-wise, it didn't make a huge difference, like what kind of like method you used. All ended up being roughly the same, strength-wise. But I guess if you like do this like 15 times in and out, like it's not as strong anymore. But also like this is just a cable cover. Like it doesn't need to be strong. Here we go. And then later we have to shoot the fan cable through here as well. Okay, then for this one, I don't think there's any screws that hold this in. I think this is really just sliding in, and then like the Bowden tube kind of locks it in place because the Bowden tube goes through here. I like the design. And then on top we put the orbiter already. Oh yeah. Cat is sleeping. Perfect. I bought this quite a while ago. The original plan was to put this onto the V0. So just putting this like on here. So this would be like this. And I think nothing's stopping us from actually putting this together already. Auto box away. So they use M3. M316, and then there's like lock nut from the bottom. Oh, which I didn't see because now we put in the screen part here, so we have to remove this quickly again. So we can slide in one of these lock nuts. Let's see. The joys of not having a manual. Oh, second. I think there's a bit of like an elephant's foot here. There we go. This goes in here, and then this goes back on top. Hi there, Raven Keeper. I already showed off your panels. But I mean, I had more than enough time now to order like the black film to cover it. I didn't do that, so now it wasn't delivered in time. Okay, so now we can put this on top, but let's not forget the bone tube. That would be like a classic me move. I think we can also like already use like small zip ties to put this like annoying cable here, and then we can maybe shorten it a bit. I like this tool that has like tons of like inbuilt zip tie mounting points. This one I put in the wrong way. There you go. Like this looks really nice. Yeah, I think we can also already. I don't want to have it too short, so I just give it like quite a bunch of extra cable. I wonder what cable is supposed to be here in front. Because here's also like zip tie spots. I'm not sure for what though. Potentially it's meant for the connector of the ADXL. Oh, I have a really bad feeling. I have a really bad feeling. I think I made a very stupid mistake. Nope. Oh, whew. I was like, there are two mounting holes here. How do we access them? But yeah, there's a slot for M3 nut here and a slot for M3 nut here on top. And then it's like screwed in from the back. I was like, do we have to remove the hot end again? But the other problem is, these are meant again for the thin M3 nuts. My M3 nuts don't fit here. Hey, so also here we will have the same problem. So we can't mount it today to that because I have to order the different M3 square nuts. But at least like, yeah, it's starting from here, starting from here. And then if I would have the thin ones, maybe I just use mine and like sand them down. I don't know. Let's see. We can also add the second screw here. I said that's the thing. Like if you don't have a kit, let alone like a printer that's like built a lot, like you encounter all these like weird like little things on the fly. You kind of have to figure it out, which is part of the fun. Before I forget it now, let's get some ball in the tube running here. I'll just use some of my random selection. Just checking. This one seems to have a square end, so I'll try to put this. Now I'm not sure how deep in this should go. Okay, this seems to be bottomed out now. I think this one might be a bit problematic. Yeah, exactly. Yeah. Here it's stuck. Yeah. Now it should be fine. Let's see. Yeah, so it's this far in, so it definitely reaches the hot end. Okay. And then I think we need to quickly check the orbiter documentation, how far out this needs to be, that we can cut it at this point. Oh, Ravenkeeper, I missed your reply. Unlucky with shipping, yeah. Took forever to ship those. But to be honest, like after they reached Oslo, it wasn't too bad, right? Like then it was like less than a week, I think. So it was really just like all the natural disasters and stuff that had a bit of an impact here. Okay, let me quickly make a bit of space. I can reach my laptop. Let's go to Chrome. So, oh, this is also not sized correctly. Let me quickly fix that. Okay, something's wrong here. Like you also don't see the address bar, but let's roll with that. Orbiter extruder menu. Well, assembly guide. I mean, this is all it's pre-assembled for us, so this should be all fine. So this is the mechanics internally, which is a lot nicer than what we have on the stealth burner and stuff like that. I'm really only interested in the okay, it doesn't say, which is a bit weird. Let's just try it out. Let's just try it out. So this is as far as it goes in. I'll just make like a small mark, and then we can quickly measure that, and this looks to be 6 millimeters. So basically from where it is now, 6 millimeter above we need to cut. I kind of forgot to print like, they're like these very nice cutting guides, which I did not print, but we can also, it doesn't have to be like super straight for the Bowden, for direct drive extruders, for Bowden on, sorry, for the all metal hot ends, it doesn't have to be hyper precise. If you have one of these like old school hot ends where the PTV tube goes all the way to nozzle, like it always had to be like super straight. Because if it wasn't like 1000% straight, you would get filament leaks. But for the all metal hot ends, it doesn't really matter. Like all that the Bowden tube here needs to do is like needs to constrain the path of the filament, and it needs to prevent the filament from getting stuck anywhere. So as long as that's the case, you are good to go. Perfect. Then what kind of screws do we need here? quickly peek over into Fusion. Did we already select it now? Yeah, M316s. This looks like M316s. Yes. Let's use the random one in my screw box. Perfect. Quite excited to use this extruder, to be honest. I bought it like really like a long time ago, like last year even, I think. And I never used it. I like how this cable is like running here, like the Pinda cable. It's quite a nice curve. And I have to hope that this is long enough for the tool port here, but I have a fear that it's not. Because it needs to go all the way over here. Yeah, I feel we need to extend the. Hey. Oh wait, no. This is perfect. This is the cable. We need to cut it off, and this goes into the screw terminal here. Ha! That might just be long enough. That would be cool. Okay, then how do we put this together here? So okay, so they have this plate here, which kind of works with what we have, so that's good. But then my question would be, how is this mounted? Tempted to rework the mini switchwire into a tiny T, like a 120 Trident. I mean, go for it. Go all for the mini, all the mini warrants. Sounds like a fun project. Yeah, I think this doesn't work. Like for sure this can't work. Like how is that supposed to work? Because like they are the screws, the screw holes. And they go like into nothing. Like there's nothing to screw them in. That is odd. Oh, and I discovered another mistake or like issue. So if we now put the extruder on, we don't have access to this one M3 nut here anymore. This one, yes, but this one because from the top not. So before we do that, we have to somehow maneuver this M3 nut in there. So let's solve that issue first. But then I think like that this tool nut mount here, it doesn't work. I mean, you can rotate that, right? You can rotate that over, which would be visually ugly and not what we have in design. But I mean, this would work, right? You can use the I have them somewhere down there printed, like these extension thingies, the same that you use on the V0. The thing is just like that the motor is tilted over, right? So that would mean that this plate is also tilted over and like also tilted in the wrong way because the yeah, so the cables go here, but it tilts this way, so it's like the wrong way. But I know that there are like nicer toolhead port mounts for exactly this angle where they. Let me quickly check. Like I have some printed parts down there. I think we might be lucky. Otherwise, we need to print that for next time. But let's first do that stupid nut here. Oh, so I don't want to force it in too much, but I think we can try to press a bit. Yeah, if I force this, it splits the part, so this doesn't work. What we could try is we can heat the nut up and then push it in. Because there's not a lot missing, like it's not like a lot too thick. Um, I don't have any. You can also try, of course, is just try to do this for a second. I'm not sure if that does anything. I'm not sure if this really removes any material. Essex is getting cold. Not only Essex, also Netherlands. I got my winter jacket out. Yeah, I feel like it's getting flat on the side. But I don't see any metal dust, so I'm not sure if this is a success strategy. Yeah, I think it works. I think it changes. Yeah, there's definitely something happening. See? I think we are closer. Maybe. It's really hard to tell if it like really takes off material or not. I think it lost the round corners here a bit, so I think it does. Ah, I'll try to push it again a bit. Yeah, I think I can wiggle it in. Oh, but it does crack here a tiny bit. So yeah, I don't want to force it too much, because if we force it and I break this part, then because it's the main part, that would suck quite a bit. Let me do this for a little bit more. Can't be missing much. Yeah, here we go. It's just not 100% settled. See if we can- Let's see. Here's this little, this tiny screwdriver. I think I should have like filed off a tiny bit more, because now it's like tight, a little bit too tight. I mean, it's 95% position. Like it's pretty spot on where it needs to be. Yeah, yeah, I think that's okay. We can quickly try to mount this. If it doesn't work, I mean, I'm not gonna mount the second one because like that's the same kind of nut. But we can quickly try if we can get this in. If not, we use a soldering iron to quickly heat up the nut a bit, and then we can push it in It's warm, like a heated insert basically. What kind of screw do we need here? Yes, this is a screw. Find a browser. That's M3 by 20. M330s. M325. I think I quickly have to grab that from my. There were like some quote unquote exotic screws in this build that I didn't buy specifically because I have this like set here also. Here we go. So let's see if we get this. Oh, so that's the one thing. Before we do that, let's quickly use a reamer and clean this out because there's a bit of an overhang. That rinse super clean. It's also the bottom one while we're at it. Okay. Yeah, perfect. Success. Yeah. This issue, this wiggle issue here on these like XY blocks, XY joints is still not solved. Like I re-greased the bearings to pack them like completely with grease, but they're still wiggling quite a bit. And I checked with Mr. DDSI on Discord, and on the Ender 3NG, it doesn't have this issue. But the Ender 3NG uses the double wide bearings here. So I think this might be something that we need to swap out in the near future here. That instead of the normal bearings, we use the double wide bearings to give it more stability. Okay, cool. But then this is also good to know that we like can easily remove this here. And this works. So this is quite good. So the only thing is I need like a second one of these like thin M3 square nuts to put in here. Hey, Sven, welcome. So, but then I'm not quite sure how to proceed here. So we can of course put the orbiter back. Oh yeah, wait, I wanted to check if I randomly have a matching mount printed. Let me quickly check my stash of printed parts. 1 second. Look at this. So this is a pocket watch extruder. And this is exactly the part we need here. Doesn't look as fancy. I might reprint that in green. But exactly what we need. I hope the angle is the same of the motor rotation. But this should be somewhat the same. Move this over here. We can continue working here. Okay. Okay, so we can mount the spacers here. These brass ones are not the prettiest, but they work. Okay, now the moment of truth. No, it's exact opposite rotation. It's exactly the opposite. Like this is like this, and this is like that. Okay, you know what? So I will reprint this anyways. It looks like the angle is the same. It's just like mirrored. We will just flip this over and proceed. And what this allows us to do then basically is we can proceed and do all the wiring, because then we see where the wires need to go and how long they need to be. And then later I just swapped it out. So this is literally like just mirrored. So basically like the cable tie point is now here and there's no spacing here. So this is not, let's not do that with electricity. And I will also be very cautious, like screwing this board down to not damage that. Let's see, do I have some random M3 screws here? I have one random M3 screw. Let's see if I find it. Let's just use M316s here. So this is only for demonstration purposes. Well, we should be able to validate the next steps with this, so that's quite good. Oh, actually, it's mounted correctly. So I already see it's like, because it's not a perfect board that is meant to be used here, it does not fit perfectly. So there's a bit of overlap between components here on the board and this cover. Let me see if I... So you decided to go with the bamboo head instead of the V6. Yeah, like I ended up making the decision that I don't want to redesign the tool head mount. And I got a quite good deal on this is this is not a bamboo hot end, or like it's a bamboo style hot end, of course, but it's a Fetus conch. So it's a aftermarket bamboo hot end. And I reused the heater and the thermistor of the hot end I initially wanted to use. So it's a compromise. Let's call it a compromise. Yeah, this definitely doesn't fit here. Like this cover doesn't fit, but I'm also not. We don't have to use this cover on this board. So there's some stuff that collides. Let's just not use this cover. Like we don't need that. Um, but this is exactly where the board will later be when we like mirror this part and print it again in green. So this is quite good. I'm just wondering, can we just back this up? Does it solve problems? No, it doesn't really solve problems. Okay, then this is the thermistor, which needs to go here. So this is really cool. We don't have to recrimp anything. I love that. This is the stepper. Works perfectly. I do have one problem here though. And that is that the thermistor cable is like a tiny bit too short. Like not a lot, but it's like just enough that it doesn't reach here. I can try what happens if I remove it from the housing. Yeah, it's like literally like a centimeter too short. Ah, what a shame. So I'm wondering what the best course of action here is. I mean, what we could do is like we can keep the JST connector and just have an extension, or we solder the cables and extend them a tiny bit. Both are options. I think like let's extend the cables. Like we have quite a lot of run here, so we can just cut it mid this section here, and then extend it here into the plug. Maybe we can also use a little bit thicker cables, which are the nicer with the screw terminals, because then we can like crimp little like cable shoes on them. Is a better option, yeah. Like not redesigning is good. Then fan wise, we have the part cooling fan, which we didn't install yet, and the hot end fan, which we also didn't install yet. So this is something I have to order. The 25 millimeter fan. So what we can wire up, and that's actually not an interesting question. Can we wire this up at all? So we need to check the pin probe because we only have on this specific breakout board, and this might already be the end of this little journey. We only have the X and stop connector, which we can use for the pin probe, but the pin probe needs also power. And power, I'm not sure how much it needs. I think the pin probe needs 5 volts. Let's quickly check what the pin probe needs, because then I think potentially we can't even use this board here at all, and we need to switch over to CAN bus and use the EBB36. Let's take a look. We only have 3 cables here. But it needs 5 volts. I am fairly certain that we don't have 5 volts on this. Is there anything here that would use 5 volts? Oh, we don't have enough connectors on this board. That will not work. We need to swap to the EBB36. No other choice, because there's nothing here that gives us 5 volt. So, hey, CAN bus it is. Let me quickly see. Where did I put the EBB? Where did I put the EBB36? Not here. I think it's, oh, maybe I put it back in the electronics box. Let me take a look here. That's the SP2209. SP. Here, there it is. There it is. The basically same form factor, but the hot end connector is a tiny bit in a different spot. So maybe, just maybe, Maybe we are lucky. Yeah, let me just bolt it on here in the same crude way. Oh, yeah, I'm screwing into the motor. Perfect. Okay, then it will stay quite loose here. Man, I mean, hey, I need to show something to the people. So this, we need to check. It's one of these three connectors here. So this is perfect. This cable works perfectly. It's just too short to plug it in, but like we managed it. So I think if we are really careful here, we can shorten these cables. Like we can remove the JST crimp. I'm trying to keep every millimeter cable here. And maybe ha, it's just long enough. Perfect. Yeah, that's what I feared. We need to see if this is like hey, you think you have enough export today? No, you don't jump over there. You don't jump over there. Yeah, jump there. Jump there. Doop. Um, I didn't tighten enough fully, but it slipped out. But it's like it's definitely long enough, so that should be fine. Let me try to rescue the other cable the same way. Yeah, and this will work. Perfect. That's the perfect length. I wouldn't have minded a tiny bit longer, but it will work. Uh, I don't have my precision screwdriver set right now. Hey, but it's also like it's not final, so I'll just use my tweezers for a second. I'm not fully tightening this to not destroy my tweezers, but I think this will work. This will work. Perfect. Cool. Then the other thing we need to do, like we can't do the fan yet, of course, because we don't have the fan. The motor cable, I mean, that's something we need to figure out how to run this. I kind of don't want to like have it over the top here. So usually what I would prefer is having it from behind like this, but then potentially if we plug it in and then screw the board down, it will work. So it's just like order of operations here. Um, a bit on the fence if this is really long enough. Yeah, if you bend it the right way, it's okay. Um, then the other thing we need to look at is the part cooling fan. The part cooling fan. And this one will be mounted to the main body on the back. I don't think we can do that yet because it will like block some other stuff. All the same here, okay. Oh, look at this. Oh, look at this. I do have the correct fans. I totally forgot that. That came from the V6 hot end. Oh, I totally forgot that. We're getting somewhere. This I will keep because I have the V6 hot end and maybe we need that. No, that's also not a. It's also a 30. Yeah, it's also 30. Well, maybe I don't have the correct fan. For some reason, it looked smaller than 30. Okay, then I have to order that. Quickly put this back together. Yeah, then only fan we can look at is this one. Bit of space. So this one will mount here. And oh yeah. So this should fit. Oh yeah, it just fits on top. So if we mount this part here, which happens with M3 lock nuts, this just goes on top. Yeah. So this is easy enough. Let's quickly do that. What kind of screws do we need there? M312s. I think that's also coming from my little stash. Quickly get that. Yeah, along the hot end, I think there's like a lot of like random screws being used. Whereas the rest of the machine has like all the same screws, basically. Uh-oh, I have 10s. I have 16s. Let's quickly try it with 10s. Might potentially be already enough. Yeah, the 10s are fine. Okay. I have a feeling we will need this again. And then there's one screw going through here. And I think, oh yeah, there's a M3 lock nut here, the square nut. But it's weird, like this one here, for example. Yeah, it's also like tied. But this works just fine. So there are like different dimensions used for M3 square nuts. So what is this screw? Find in browser. M330. We have a bunch of those. Let's use. You see if this mounts correctly. I could have used the reamer to clean this out, but okay, this looks fine. And then this goes here. So this doesn't have to be like super long, but I also would try to route the cable a little bit here on the back slash top. Ideally, there would be like a zip tie at a point here. Like I said, like there's so many on this tool head, but now there's none here. I'm pretty sure that there's like a intended way to run this cable. Yeah, we mounted the right way. So the cable comes out here. Let me see. I wonder what these four dots here are. No clue. Yeah, I think the cable is just like supposed to go up here, like without any guide or something. So it's just like this. Potentially you can also just do it like this, and maybe use a tiny bit of tape here to hold it on the side. So then it comes out directly where it needs to come out. And this is a PWM fan, so we also need to quickly check how we can set this up here. That might be also like interesting thing. So we most likely need to crimp it on two connectors. So let's check the pin out there. Hi Dom, welcome. We also need to check the pin probe. No, that did not work out. But yes, we have brown, black, blue. Let's see. So let's quickly open the documentation. Let's open the documentation. EBB 36 pinout. Gosh. Open image, new tab. So I think that's why it's up to the end stop pin, the pin probe, because it has like a JST connector. I like it more than just the bare header. So we basically need 5-volt ground and one of these three. Like I don't think it makes any difference which one is which. Let's quickly check again. So we have 3 wires here. We don't have the thermistor. This looks like ours. No. Yeah, so black is a signal. I think the important, yeah. So I think there's super pinned and a pinda, and I think I have the bad one. Yeah, the pinda V2 has a temperature sensor, which we don't have. So for us, it's basically the black one is the signal. Okay, then let's crimp a cable on that. So knowing that we want to have it on this port here, I think something like this is a good length. Let's give it like a little bit extra just in case. And then for me, the question is, let me quickly practice it. So we need to remove the isolation without damaging the inner cables, ideally. Almost. I think it's usable. And damage the black cable a tiny bit here. It should be fine. No, where's the bottommost? For that, let's actually use a tiny bit. A tiny bit here. A tiny bit of heat shrink just to cover this black cable that I accidentally damaged a bit. It's just almost a bit too short. Let's first do the JST plugs. Let me not forget to slide it over, and then we can later just use the heat shrink to cover it a bit. This oh, that's a small one. Let me quickly check. I always crimp the wrong ones. That's the small ones. But we need to check if I have a housing for that, because it's like 5 pins. I don't think I have a 5-pin housing for the small ones. I have 6-pin. I mean, for sure it was delivered with the EBV. Quickly check that. It's in my electronics box. I keep all these connectors that come with these boards in here. Here it is. Let's see. Just quickly double check. This fits. Yeah, okay, that's the connector. Perfect. Then the challenge now becomes just like more or less crimping them first try. I'm completely off camera. I'm super sorry. Didn't 100% close the front thingy, but I think it's fine. Okay. So then we said black is the signal. Blue and brown is blue's ground, I guess. Yeah, blue's ground. And brown is 5-volt. So at this connector, the brown is the first. Then blue. Hui. Yeah, it's like it's a bit too wide. Like the crimp is not fully crimped on the back. Let me see if I can crimp that over. Nope. Yeah, that's it. Okay. Where are other tweezers? One pair of tweezers? Where's my second pair of tweezers? Yeah. I have way too much stuff here. These are a bit stronger, so I always use them to like push pins in and stuff like that. And and then we said like we cover the black cable damage isolation a little bit, so we just cover the end here with a tiny bit of heat shrink. I'll let it quickly cool down, but this should work perfectly. Cool. Then for the fan, so we said the cable can be quite short. Let's put this back. Don't need any special connector for the fan. So the fan connector can be quite short. And I think I literally will run it like this. So the only things that we need to see, so the fan, we need 24 volts. And we need ground. And we need one PWM signal. Initially, I thought everything would be done in 1 month, but it has been a year since I started building. Choosing the right parts itself took a lot of time. Yeah. Projects like this take always like a lot longer than you initially think. Let me see. So I think so I would just use the PA0 and V in as ground. And then let's see, what else do we have? We have the RGB connector, which we also not gonna use. But I think it's then best to, I don't want to like cross, no, it needs to be a separate pin. So then I think we need to use this header here on the bottom, the DuPont header. Or we use the RGB header. Let's roll with that. You know what? Let's roll with that. So we use the RGB header here and only grab the V in from fan 0. So we crimp this into two connectors. So I'm just roughly gonna cut it to length. So the red one will be like this. And then the other, because also technically we can get the speed from that if we wanted to. To do that, we would need now ground and two. Okay, then let's wire this to the probe connector. Let's give me a little extra like this. Let's roll with that. Let's roll that. So basically, we have two connectors. We have two connectors. One is just the 24 volt. And then the other three are DuPonts. Okay. And those are DuPont. So we need DuPont female here. And then we need a DuPont connector with 5x1. We have that 5x1. Oh yeah. That did not work out. So I always squeeze them a bit that it's on the cable. That did not crimp cleanly. It holds on, okay. I'll take it. I think we need to use the smaller crimp setting with these. Remove a tiny bit more isolation for this one. Okay, 1, 2, 3. So then these, I wonder why the white cable is so much shorter. But yeah, doesn't matter. The I royally screwed it up before, but it doesn't really matter so far. So let's just use this one as the ground. So this is the outermost. And then we have two sensor, like two like wires that are just like GPIO. So it doesn't really matter which one is which. Uh-oh. Why do you not log in? Why does this one not lock into place like a good two-point connector? Oh, it does. Okay. And then this one is one free and here. A bit weird, not sure why. Okay. Okay. Well, that did not work. Oh, we're missing JST holder. And the VIN is on the bottom. Maybe it would have been nicer to use. One second. Let me remove one. So no, it's fine. So we have the ground connection all here. So this should be okay. Let's quickly screw it back in. How many working printers do you have? Sorry, I'm really bad with the chat again today. Um, I mean, working. They're all working. I have the 2.4, which is working. I had a bit of trouble with this one recently, but I fixed the issue. There was like something wrong with tap. So that's always like, is it working? Yeah, it's working. I fixed it. Then I have the switch wire that we also built on stream. This one is working amazing. And I have the V0, which is also working very reliably. So 3. And in total, with this one, I have 5. Oh, I also have a Bamboo Lab X1 Mini. X1, A1 Mini that I have for testing purposes. And that one is also working. No, did we cut a cable to go too short? Oh, it's just long enough. That's why I should always, sometimes I forget to add my extra 1 centimeter wiggle room. There's also, of course, the white cable that needs to be, because the white cable is the shortest of all of them, and it needs to go the furthest away. Let's swap the white and the blue one, because for those it doesn't matter which one goes where. It should make that a lot better. Yeah, perfect. A lot better. Perfect. The only thing that I can like think of is like if I want to have the ground on this connector here as well. But then basically it's a GPIO pin that we have to set to always false. But it works. That works. So these are fine. Let me unplug that and unplug that. The only thing is that I don't like with these two-point connectors, they don't have like a orientation. But if I plug this in the wrong way, nothing bad will happen, I think. So that should be fine. Okay, that's all the crimping. I have a 0 and a Retric 300 trying to decide if I build a Micronaut VZ bot next or just buy bamboo for something I don't have to mess with. To be honest, um, having one printer that you don't have to mess with is nice. But also you can just have like, that's like, this machine is the one machine I'm not gonna mess with a lot. That's what I decided. I want to make the tool changer, maybe in the future. At some point, but for now, this is the machine that I want to rely on. So basically, it's working fine, and I just leave it. We do one more change though, which is the cartographer probe. But after that, I'm not gonna touch that. So, I mean, this is good. This is good. And then here, I think really like this cable, we can do it from behind. That's also fine. Perfect. And this is, yeah, it's this one here. This works. This is a Toolhead. I don't like how stiff this Pinder cable is though. Like I feel like it puts a lot of strain on the connector now. But yeah, should be fine. And then again, like the cables for the hot end they're really short. Like I will think of. I think if I really tighten them down there, it will be fine. Otherwise, like we will just shorten them like a tiny bit and extend them. And then the fan is also in place. The only thing that's a bit annoying, like you cannot remove this without removing the fan. So there's always like an extra step there. I guess it's fine. But yeah, and I think the hot end, like the tool is mostly in place. The only thing missing is the fan here. And that I will order. And use Bamblop AMS. I don't have an AMS system. Redux is my old reliable. I know I can just send the file and it will print. Then I would just recommend just keep the rhetoric as is and just get what was the options you had? Micron or VZBot? To be honest, I think the Micron is a more fun printer because the VZBot. So if you have already like a 300 rhetoric, I would go with something smaller. So if you go VZBot, I would go with the what's the small one, the 250, I think. Or the Micron is the same size as this one, and I think it's really nice. Like the V0 is very very small and very fast to like heat up and get starting, so it's a very nice machine. But this one is kind of like, I think, the sweet spot, like the 180, because like it can print quite a bit more than the V0, and it's almost as fast to get going. So I think that's a really nice sweet spot. 235, yeah, VZBot 235. I would go for the Micron, I think. It's also like with the four motors and the belted Z, it's kind of like a cool build. Um, so it's kind of fun. I think Amemlab is like the Apple III printers. They have a lot of restrictions, but offer smooth experience without much hassle. Yeah, to be honest, like I also had a bit of trouble with my A1, so I think it's a bit overhyped in a certain sense. Like it's never as good as it looks on video. I think Bamboo Lab just has like shitloads of money for marketing, because Bamboo Lab is, I might be wrong, but it's the only 3D printing company that is like investor funded, really. Um, so they just have lots of money to burn, and like the machines look nice, but they're not like that much better than what other companies offer. My hot take. Salad fork. Oh yeah, salad fork is also a nice option. Okay, cool. But I think then I kind of like got as far as I can get today. So things I need to prepare for next time. The black foil for the panels that Ravenkeeper made should be there by next time. So we can definitely put in the two back panels here. But you know what? I see Ravenkeepers here. Let's just I made such a mess. So quick panel check time. So this is a side panel that fits well and also has the cutout here. We don't have that part here that's yet. So this will be here, and then the panel goes over. So this will be like very nice. Then let me see, where can I park the panels? Here. Then. If we flip this whole bad boy over, see, so this is this panel, which I guess that fits. It's a bit of an odd shape here, like it's very close here. I know originally, I think the motors were supposed to mount it outside, and we decided to not do that for some reason. Maybe. But yeah, it fits. This works. I'm not sure yet if I keep that transparent or not. Do they fit? I mean, yeah, I mean, they seem to fit. They seem to fit. The only thing, this one here docks on like, oh wait, did I? No, no. This one touches the stepper motor here a bit, but it fits for sure. This will be fine. Otherwise, I make like a teeny tiny like adjustment here. So this is fine. Then this is the front door. The front doors have the fun side effect that they don't have any hinges in the cat, so there's some opportunity to for us to make something nice. But these are the front doors. And then we have these are the back panels. So we need to kind of figure out how this goes in here. So yeah, I think this one's actually this side. Again, like this part is still missing. And then I think this will just be, yeah, over here. So this also fits. This looks good. Let's see how they exactly align, but this is kind of like where it's supposed to be. And then this one. Now, which one? I guess it's this side. I mean, I can't put this now here because of the cable, but that fits for sure. And last but not least, we have the most boring panel, which is side panel here, which is the only one that's perfectly square. All the others have like funky cutouts. So that works. That obviously bought 48 volts, not to keep them slightly different, to lure my wife into thinking I need another one. Yeah, you need to have different capabilities for each machine. But to be honest, like I kind of do the same. Like I mean 2.4 is it's big, it's slow in a certain sense, like it needs like quite long to heat up. So but this is the unique capability. The V0 is just like perfect for like quick prototyping and stuff. I use that actually still quite a lot over the 2.4. Whenever I need to print something quickly, I fire up the V0. The switch wire is my PLA monster. It has 0.6 nozzle, and like most parts that I print for like around the house for parts are PLA. And that turns them out very quickly. And this one is a bit often, it's also like a PLA machine most likely. But more like a more detailed one. I need to see. Like I need to find like a unique use case for this one, but it has a different hot end. It has 0.4 millimeter, where the switch wire has 0.6. So let's see. But yeah, um, they all are a little bit different, which is important. Uh, Hi, Luan Waka. May I ask about your experience in handling the coplanetary issue of aluminum bars during installation? What do you mean by coplanetary issue with aluminum bars? Do you mean like that they're like parallel? Usually what you do with that is you choose one, you just fix that up. Like in this case, basically, because these two actually don't need to be perfectly parallel, but this and this need to be perfectly parallel. So usually what you do is like you take this one, you adjust it. Like I don't have my calipers at the moment, but you use calipers. Where are my calipers? Oh, there, oh, there. One second. So what I did in this case, for example, you take calipers and you don't measure, you just use them to copy this. So you just dock it against this part and this part in this case. There's a little screw here that you can tighten, and then you can copy this distance to this part. So this is still loose, you move it forward and then you tighten this. At this point, this bar here is perfectly parallel to the front of the frame. The rear bar is still loose. And then what you use is you use your bat in this case. So you move it all the way down. You move it all the way down. Yep. That, where are you? Interesting. Okay, so I found the issue. Oh, the screw is too long. Okay, we found the issue here. Okay, I will fix that. The screw here on the back is too long and collides with this part. It peeks out too much. I will take a look at this. But yeah, so you move then basically the bed all the way down. So the front bar is already, the front bar is parallel at this point, and the rear bar is loose. So you move it all the way down the bed, and then you fix this part here. At this point, these are fixed, and this is fixed. And now you move the bed all the way up. Don't do that with mainboard plugged in. And now when the bed is up here, you also fix the top part. And at this point, you basically use the bed. The same goes for the tool head. You use the bed to copy the distance from the bottom to the top. And then you know that these two are perfectly parallel because you use the bed as a template, so to say. Not sure if that makes sense. Does the frame have to be exactly 90 degrees or is a 1 optimum difference acceptable? It has to be pretty much 90 degrees. It depends a bit on how the motion system is set up. So if you consider this printer, this frame technically wouldn't need to be 90 degrees. The only thing that's important is that these bars are parallel and that these are 90 degree to the tool head here. As long as this is in like in the right angle, this motion plane and this motion plane, you're fine. In general, like get your frame as much 90 as possible. I know you're building like a relatively big printer. So if you have like, let's say like something like a 300 and you're like half a millimeter or a millimeter off, then that's not ideal, but like kind of acceptable. But if you print like build like V0 and you're like 2 millimeters off, then that's quite bad. So it depends a bit on the size of the printer, but in general, don't rush the frame because everything you do is based on the frame, so to say. So if you rush the frame, you will just have more issues down the line that you need to correct. Warren Design says measure diagonal to check squareness. Measurements should be less than 2 millimeter difference. So there's still room from error, but as 90 as you can. Yeah, exactly. And at the 2 millimeter, I think it depends on how big the frame is, right? On a V0, 2 millimeters is a lot more, like proportionally, than on like a 2.4 or something like that. So it also depends a bit on the frame, yeah, on the size. Okay. But then yeah, my homework is in this case shorten the screws here, or at least like this one. So I might just swap this screw for like M330 or Shulknet. I'll see. I'll do something there. And the other thing is I need to order the thin M3 screw, the thin M3 square nuts that we can put one in here and mostly some other spots. And what else? Oh yeah, I need to print this part here, the toolhead board mount and like mirrored position. I'll check if I find a nicer one. This one looks a bit ugly, to be honest. But there are for sure nice options for the Overture. And I think that is it. Oh yeah, and I need to order the fan. So I need to order the fan, the M3 nuts. I need to print the mount, and I need to shorten the screw. Oh, and I need to shorten the other screws here for mounting this one. So I have a bit of stuff to do. I'm building the frame from for the last 3 months. Okay, you take your time. You take your time. But yeah, in general, like it's okay. If you need more time on the frame, this is what it is. I don't think it makes sense to proceed until you're happy with that. But I think, like as Ravenkeeper said, like if it's within tolerance in a certain sense, I guess it's fine. Cool. Okay. Well, enjoy your weekend. Oh no, my dragon is also waking up. So enjoy your weekend. See you next week. Bye. My frame is 780 by 650. 2 millimeters good on. 2 millimeters good. See you next week. Bye.